that example. So 3.12, it says a rectangular area around a farm stall is to be fenced. So now we're talking about fencing here. So already we must start ringing surrounding maybe a yard, or let's say the farm. The number 2, one side needs a stronger fence, which costs 250 rands per meter, and the other side costs 150 rands per meter. So which means the other side costs 150, but one side need to be stronger, it costs 250. Then we are asked, what is the maximum area that can be fenced if 5,000 rands is available? So if 5,000 rands is available, what is the maximum area? What is the maximum area? So now we're going to retract, we are into optimization. So we're having a rectangular area around a farm. So we understand when we talk about the rectangular area, we need to start drawing a rectangular, let's say, shape. So it's to be fenced. Then one side needs a stronger fence. So first of all, we can say maybe this is the breadth. Can I use B? This is the breadth, this is the, can I say length? So it's L and B. So it says one side needs to be stronger, needs a stronger fence, which costs 250 rands per meter, and the other side cost 150 per meter. So we need to know what is the maximum area that can be fenced with if 5,000 rand is available. So the first thing that we have to do, so we know that one side need to cost a certain amount. So per meter, so let's say we can assume maybe one side is this one. So it must cost, let's say 250 rands per meter. And then it says that the other side needs to cost 150 rands. So we know that it means that this side must cost 150. Put the unit per meter. And 150 per meter. Okay. And this other side must cost 152 and 50 rands per meter. So it needs to cost 150 rands per meter. And then what is the maximum area that can be fenced if 5,000 rands is available? So what we're going to do, first of all, we need to try and utilize the perimeter, because we understand this side will cost 250, this side cost 150, the other side 150, this side 150. So if, let's say, 5,000 rand is available, so we need to maximize the area. So we know that for the whole perimeter, we need to cover it with 5,000 rand. So first of all, what we're going to do, we know that before we even go further, the area of a rectangle, it is length times what? Times breadth. We need to know what is the maximum area that can be fenced if 5,000 rand is available. Then number 2, as much as we know about sides, when we talk about sides, then we need to think about perimeter. Though for, I just want to look for the formulation, but though for a rectangular, we cannot forget. We know it's always either 2 times the breadth, 2 times the what is it? The length. So according to perimeter, let me say perimeter of a rectangle. Perimeter of a rectangle. It is always equals to. So we know it is going to be breadth plus the other side of the breadth plus what? Plus the length plus the length. With perimeter, you add all the size of the shape, size of the, let's say the shape that we are given. So for all these sides, we know that for that perimeter, it must be covered by what? 5,000 rand. So what we're going to do, I'll say 5,000 rand, I can say per meter. So it has to be covered by 5,000 rand per meter. Then what we're going to do, we know that, let's start with one breadth. This one side here will cost 150. So in fact, let me just remove the meter. So we know one side, one breadth. So I'll say 150, one breadth must cost 150. And the other side, I should have said two times. It must cost what? The other breadth must cost 150. And the other length, where's the other length? Same thing, it must be 150. So the other length, 150. And therefore, let me just add it down here. So therefore, plus the other side, which is 250, must cost 250. Let me say it's the length. So it's the length. So what we're going to do, we are utilizing this because we need to maximize the area. So we're going to either work with one function because we want to try and apply differentiation. So remember when you need to determine a maxima and minimum. Mhm. By 250, yes. Yeah, 123, 123. Then plus the stronger side. They said this side must cost 250. So that's why the price is higher. So it's about price now, that this length must cost this much because it need to be stronger. So it's the statement that I was reading there. So it says that one side must be strong. It must cost 250 rand per meter. So one side. No, they don't. No, they said one side. Remember, this is a price for this 250 is for this one. So they said one side must be stronger. We can change and say we want it to be this side of 250 and here 150. So they said the other side must be 150. So hence I wanted you to refer to the notes there because this is a theory. When you read it, you must read it three times. So three sides must be 150 rands per meter, but that stronger side must be 250. It must be 250. So we want to try and utilize applications of differentiation. So we know that when you need to maximize area or minimize area, so when we want to determine minimum or maxima, we know that we are going to derivate, and the derivative at the turning point, I can say turning point, or maybe at the maximum. So the area, we can equate it to the derivative of the area. We say change in area, it must be zero. Or let me say the derivative at the maximum or minimum, therefore m is equals to zero there. That's how we apply differentiation. Okay, so I want to try and work out and have at least one variable. We want to try and go and maximize the area. We need to maximize the area when it has costed this much. So I'm going to say for per meter it costs 5,000 rand, but let's try and add up. Let's say, can I say like terms? Let me say like term. So here is going to be 300, right? So it's 300. Let me say B. So normally sometimes they use X and Y. We can utilize that, but we have worked with the breadth and length. So 150 plus 250. It's how much? It's plus 400. Yeah. So let us try, and now we need to take this and substitute into the area then. So, but at least let's make one variable subject of the formula. We can make L, we can make B. So we can choose. We're making B or divide by 300. Divide by 300, so it's at B. So divide by 300, 5,000 divided by 300. Okay, in fractions, it's 5/3. It's 5/3. 5. Hmm? It's 50. Okay, 5,000 divided by 300 is 50/3. Okay. All right. So, because we said we're taking this 400 to the other side, but we're even dividing 400, so it would be minus. So it's 4/3f. Okay. So we're taking 400 to the other side and divided by 300 on both sides. So we have that. So I've made the following to be in terms of B. So I'm going to substitute B into the area. We want to maximize the area. So area is going to be equals to L. Okay, it's in terms of B. So we're going to have L. So the breadth we said it's 50/3 minus 4/3. L is in it. L is in it. So what we're going to do, you can multiply out in there and have the area to be in terms of L now. We're going to derivate that the area is dependent to L. So it's going to be 50/3 L minus, so it's going to be 4/3 L squared. So let us maximize the area. So we know in applications of differentiation. So we're going to say that we're going to derivate area in terms of the length, isn't it? Because it's dependent to L. So it is a function. It is our function. So it's going to be dA/dL. Therefore, it's equals to. So derivative of this in terms of L. So it's dL/dL. So which is 50/3. So derivative of 4/3 L squared is minus 8/3 L. So multiply by 2 and subtract 1. So we've utilized power rule. So the function is in terms of L. So you'd agree with me that I just want to use graphs, though we're not supposed to do that. So you'll remember that at the maximum, what happened? M is what? M is 0, isn't it? So we use that type of method. We know that M is 0. So therefore, this can help us to determine the value of L. So we know that, the A/dL is equals to 0. Therefore, at the maximum, we know that dA/dL is equals to 0. So therefore, we're going to have 50/3 minus 8/3 L. Now let's solve for L, taking 8/3 to the other side. It's going to be positive. But we're in N5, please divide on both sides by 8/3. So divide 50/3 by 8/3. So which is going to be 50/8. It's 50/8. So take 8/3 to the other side and divide by it to get L. So I'm getting 50/8. We don't know 2 goes 25 times into 8, it goes 4 times. It's 25 over.
Does it represent the monthly listing, or does it represent the net, the moment space that you have? Will be a second space plus 5,000.
Yes, it represents the length. Yeah, that is the length that is we're going to. Yeah, can I say it's going to cost for the area? For the area, so the length that we're going to have, that's how much it's going to cost. Length times breadth. Yeah, so that is the length of the fence. Yeah? So that is the length of the fence. If you wanted to prove if really it's a maximum, you can derivate the function twice. I think this is a theory that you need to recall too. So yeah. Remember to prove if you have a maximum or minimum. Remember you derivate it twice. and substitute the value here into the second derivative and see if you're getting a negative or positive. So if it's negative, it means that it's a Z phase, it's a maxima, right? So if it's a smiley face, it's a minimum, it's a positive value. So though this we don't have two lengths, there's other functions when you are going to, if let's say it was a, what type of function will be that? Let's say maybe type of area. So if let's say we derive it, or when you factorize and find the solution, find that you have two lengths. So you have to prove which one is a maximum, which one is a minimum. So but at least here we just have one length. But I'm saying you have to derivate now the area twice dA squared over d it's dl squared, isn't it?
Yes.
So derivate the area twice in terms of the length for the second time. So it's going to be equals to, so this is going to be 0, therefore minus, it's going to be minus what? 8 over 3, isn't it? Yes. So here there's no way we can substitute the value of L. It proves that this is a maximum. Remember, a negative value to represent what? Your maximum. So negative side face. No negative, which one else? Now you watch those things. Okay. So we see that, oh, we're at the maximum. So it's true that is the maximum length. So we cannot go further. So you can know that here you're at the maximum. So if there was no value to substitute, we're at the maximum.
We want the maximum for the rate now that you substitute make L subject to the formula.
No, now we are done. We just need to substitute back to B and get the breadth.
Oh,
Yeah. So here I wanted to show you that you can show that, oh, to make, in fact, this is the maximum length.
no, but you can bring me and not currently with the second side of the study.
We are derivating the area for the second time in terms of the length. So remember what is second derivative? We are derivating this function for the second time. Derivative of 50 is 0. Derivative of 8 over 3 in terms of L is negative 8 over 3. So when we're done, if let's say there was L here, we know L is to the power of 0. We're going to substitute this. It's still 1. So it still shows you it's a negative value. So therefore we know, oh, that is a maximum. I was going to say 10, but it's a maximum length. No, it's not dividing, it's a second derivative.
Yeah, the second.
Yes.
Yeah.
Area.
Length.
No, in terms of length.
In terms of.
Remember, area is dependent to length. I know you're used to dy over dx squared. We're not derivating y now, it's area in terms of length. So I know it's nothing difficult, it is the area. What's happening? 4? That's fine. So let us find, yeah. They're making notes. So 50 over 3 minus 4 over 3. So length we said is equals to what? Length is equals to 25 over 4. 25 over 4. So you can write down the breadth value there. Was it squared this one? We're finding breadth. So quickly there, just want to conclude the area. So B is equals to
25 over
25 over
3.
25 over 3. So that's 25 over 3. So therefore, so therefore we know that our breadth is going to be 25 over 3. So now let us make it to maximize our area for maximum area to be covered by this amount by 5,000 rand. It is going to be equals to. So we know that L times B, we did that, L times B. We said it's equals to, L is L, 25 over 4 multiplied by 25 over area, that's what we have. Yeah, but I just get it over 12. So what is the value?
6.5 over 12.
So 625 over
12.
over 12. Or you can leave it in decimals. So it's going to be equals to
52.083.
52.83.
083. 083. Yes.
83. So it is what meters? It's meters what? Meters squared. So this is the maximum area that can be covered by 5,000 rand for this for this side here, for this side. 5,000 rand perimeter can cover this sides, or for maximum area is going to be 52.083. So that is the maximum area to be covered by 5,000 rand per meter.
So how would you know that you're correct or your answer is correct? Because you're not giving the equation, you have to make your
Yeah, hence you have to utilize your own equation. So, but you need to make sure that perimeter, we don't need to make a mistake. We know it's length plus breadth plus breadth. Then is equals to the total perimeter. So total perimeter need to be covered by 5,000 rand per meter. So for each length must be covered by 5,000 rand. For area, we know it's L times P. So the main mistake that is mentioning here, if let's say for example, you divide incorrectly here. So, but for some point, if you have a maximum length, sometimes if let's say you have tried to derive your areas, sometimes if it shows you that you're getting a minima with just one length, something will be wrong there. So this can help you there at some point when you derive the area for the second time. So if it gives you a minimum, we are speaking about maximum. It must be maximum length, maximum breadth. Okay. All right. I just want to cut it here because I know you have to attend.